for decades, if you saw three specific letters on the back of a Mercedes-AMG, it signaled one very specific visceral experience.
Right, it meant you were about to hear a completely unhinged twin-turbo V8 engine.
Exactly. I mean, it was an era defined by just mechanical violence. The cars were loud. They literally vibrated your ribs when they idled. And, well, they demanded a lot of physical wrestling from the driver.
It was a badge that essentially represented internal combustion at its absolute peak.
Yeah.
You were buying into a legacy of controlled explosions and heavy machinery.
But today, we are stepping into a reality where that entire paradigm has been, it's basically been dismantled and reassembled into something almost unrecognizable. So welcome to today's deep dive.
We are unpacking a vehicle that's experiencing this fascinating, almost poetic identity crisis.
Yeah, we are looking at the highly anticipated, completely reimagined, all-electric Mercedes-AMG GT four-door coupe.
Which represents a profound pivot. Mercedes hasn't just added a performance EV to their lineup. They have entirely replaced their flagship gas sedan with a battery-powered vehicle.
Right. They are betting the absolute crown jewel of their performance division on electric architecture. And to understand the sheer scale of what they've built, we're pulling from a really diverse stack of sources for you today.
We've got a fantastic, really dramatic breakdown from Italy's Corriere della Sera, which paints a vivid picture of the car's speed and, its presence.
And we're balancing that with a deeply detailed, highly technical piece from Arena EV. Plus, we sifted through this massive, dense technical dossier straight from Mercedes-Benz themselves to get to the underlying physics.
And to keep things grounded in how human beings are actually reacting to this thing, we're diving into a delightfully contentious reader comment section.
Oh man, the comments are something else. But the contrast between the clinical engineering in that Mercedes dossier and the emotional reactions in those comments, that's really where the story lives today.
Yeah, the engineering achievements are monumental, but the public reception reveals a lot of anxiety about, the future of performance cars in general.
The core premise here is just a massive contradiction. This car boasts up to 11,169 horsepower. It's a technological marvel. But through software and sound design, it's desperately trying to convince you that it's a gas car from the past.
But before we get into the psychology of, faking a V8 engine, we have to look at the brute force that made them abandon the real V8 in the first place.
Oh, right. Because you have to look at what they gained in the trade-off. This isn't just a standard Mercedes EQ model that they tweaked and slapped an AMG badge onto.
No, not at all. It sits on a bespoke EV-only architecture called AMG EA. It shares essentially no underpinnings with standard Mercedes passenger EVs.
It was built from the ground up strictly for high performance. And the numbers they squeezed out of this platform feel, honestly, almost fictitious.
Yeah, the flagship version, the GT63 4MATIC Plus, uses a tri-motor setup. So one motor in the front and two in the rear.
And combined, they produce 1,169 horsepower, or 860 kilowatts if you prefer, plus an earth-moving 1,480 pound-feet of torque.
Which is insane. Those figures elevate a luxury Grand Tourer well past traditional sports car territory. You're directly in the realm of modern hypercars.
Totally. And the acceleration data in the Mercedes dossier backs that up. They claim 0 to 62 miles per hour, 100 kilometers per hour in 2.1 seconds.
Though it's worth noting the dossier mentions this is measured with a 1-foot rollout.
Right, which, for those of you who don't spend your weekends at the drag strip, a rollout is an industry standard where the timing clock doesn't actually start until the car has moved forward exactly 1 foot.
It shaves a few tenths of a second off the official time.
Yeah, but even without that rollout, from a dead stop, it hits 62 miles per hour in 2.4 seconds, which is just physically violent.
With the top speed electronically limited to 186 miles per hour.
Right.
But the sheer acceleration isn't actually the most impressive engineering feat here.
No,
the true innovation is how they're generating that power, using what are known as axial flux motors.
Ah, right. The underlying technology for these was developed by a British company called Yuasa, which Mercedes saw so much potential in that they just acquired the company outright.
Yeah, they bought them completely. And to grasp why axial flux is such a big deal, we should visualize a standard electric motor first, a radial flux motor.
Okay, so in a standard EV, you have a stationary hollow cylinder called the stator, right? Which generates a magnetic field.
Exactly. And inside that, you have another spinning cylinder, the rotor. The magnetic forces pull the inner cylinder in a circle. It's a relatively long tube-like shape.
That radial design has been what? The industry standard for a century.
Pretty much. The magnetic flux runs perpendicular to the axis of rotation.
But an axial flux motor changes the geometry entirely. Instead of cylinders inside of cylinders, it's more like a sandwich. Or think of two vinyl records spinning on a turntable.
That's a good way to picture it.
You have two flat, thin discs, the rotors spinning on the outside, and they enclose the stationary stator in the middle.
Right. And by arranging the components that way, the electromagnetic flux runs parallel to the motor's axis of rotation. This fundamentally changes the mechanics.
How so?
Well, because the rotors have a larger diameter relative to their length, the magnetic forces are applied further away from the central shaft. It's just basic leverage, you know. You get significantly higher torque density.
And the packaging is incredibly efficient, too. The dossier notes that the rear motors in this car are only about 8 to 9 centimeters wide.
They're essentially the width of a thick hardcover book.
That's wild.
But beyond the space savings, this parallel magnetic arrangement allows for much better cooling. I mean, in the high-performance EV space, doing a 0 to 60 sprint once is easy.
Right, any EV can do that.
The real challenge is doing it repeatedly, lap after lap, without the internal components getting so hot that the computer has to drastically reduce power to save the motor.
The dreaded thermal throttling.
Exactly. But because the axial flux design has a larger surface area relative to its volume, it sheds heat far more effectively. It allows for sustained, repeatable peak power.
But generating 11,169 horsepower consistently means feeding those three compact motors a monumental amount of electricity. And anytime you push massive amounts of energy through a system, you encounter resistance.
And resistance creates the ultimate enemy of performance, which is heat.
Right. So to figure out how to feed these motors without literally melting the energy source, Mercedes turned to their high-performance powertrains team in Brixworth.
Yes, the exact same engineering division responsible for developing the hybrid power units for the Mercedes-AMG Formula One cars.
Talk about a resume.
Seriously. They were tasked with designing the 106 kilowatt-hour 800-volt battery for this GT.
And they didn't use the standard rectangular pouch cells or typical battery modules you find in, like, most consumer EVs.
No, the dossier highlights a unique cylindrical cell design. They're tall and narrow, 105 millimeters high, and 26 millimeters in diameter.
They also swapped out traditional steel housings for laser-welded aluminum to improve thermal conductivity. But the method they used to cool these cells is what really stands out to me.
Oh, it's fascinating. In a typical electric vehicle, the battery pack is cooled as a single large unit, right? Often by running coolant through plates that sit underneath the module.
Now, it's indirect cooling.
But in this AMG, they developed a system where an electrically non-conductive, high-tech cooling oil flows continuously around all 2,660 individual cylindrical cells.
So every single cell is physically bathed in flowing coolant.
Which is absolutely necessary when you look at the charging capabilities they've engineered into this system.
Yeah, the article in Corriere della Sera was particularly focused on this detail. Mercedes claims this car can accept up to 600 kilowatts of DC fast charging.
600 kilowatts, that is staggering.
It is. That allows the car to go from a 10% charge to an 80% charge in a mere 11 minutes. Yeah, it has roughly 286 miles or 460 kilometers of range in the time it takes to walk into a rest stop, use the restroom, and buy a coffee. The maximum range sits at 435 miles on a full charge, by the way.
Pushing 600 kilowatts into a battery pack is an almost unfathomable rate of energy transfer for a passenger vehicle.
And this is where my skepticism kicks in a bit. I mean, I know that if I plug my smartphone into a 30-watt fast charger, the back of the phone gets uncomfortably warm.
You can feel it immediately.
It's a fundamental reality that excessive heat degrades lithium-ion chemistry over time. So if you blast 600 kilowatts into a car battery in 11 minutes, the internal resistance should theoretically create enough heat to severely shorten the lifespan of those cells.
And it would under a traditional thermal management system. A standard cooling system is reactive, uses physical temperature sensors thermostats that monitor the battery.
Okay.
When the cells get hot, the sensor registers the heat and the computer turns on the cooling pumps to bring the temperature back down.
But at 600 kilowatts, if you wait for the physical temperature to spike, the chemical damage to the cell is already happening, right?
Exactly the problem they faced. So their solution is a system they call the Central Coolant Hub, or CCH. Instead of relying solely on physical sensors to react to heat, the CCH uses predictive mathematical models and virtual sensors.
Wait, virtual sensors?
Yeah, the computer monitors the specific amount of electrical current flowing into the battery at any given millisecond.
Oh, I see. So it calculates the internal resistance based on the incoming current and predicts the exact amount of heat that will be generated before the temperature actually rises.
It anticipates the thermal load. By calculating the impending heat spike, the central coolant hub preemptively increases the flow rate of that cooling oil around the specific cells receiving the charge.
That's incredibly smart. So it neutralizes the heat at the exact moment it's generated.
Exactly. This predictive thermal management is what allows the battery to survive those 11-minute charging sessions without catastrophic degradation.
But, the sheer computing power required to manage the battery temperature brings up a much larger theme with this vehicle.
For sure.
We've established it has hypercar acceleration and Formula One derived thermal management, but it weighs an astonishing 5,423 pounds.
Or 2,460 kilograms. For context, that is heavier than many full-size gas-powered SUVs.
Right. So we have a vehicle with the footprint and weight of a luxury barge, but the performance expectations of a nimble sports car. The only way to make 5,400 pounds change direction quickly is to aggressively manipulate the laws of physics.
The heavy battery pack is the great compromise of the modern performance EV. To counteract that mass in a corner, engineers have to utilize incredibly complex hardware and software matrices.
They're artificially recreating the mechanical agility of a much lighter car.
Yes, and looking at the chassis technology, they are attacking the weight problem from every possible angle. First, there's the active rear axle steering.
Right, so below 50 miles per hour, the rear wheels actually turn up to 6 degrees in the opposite direction of the front wheels.
And by turning the rear wheels in the opposite direction, it physically tightens the turning radius. It creates the sensation of driving a car with a much shorter wheelbase.
Which allows this heavy vehicle to sort of dart into low-speed corners.
Exactly. Then, once you surpass 50 miles per hour, all four wheels turn in the same direction to provide stability during high-speed lane changes.
But steering is only half the battle, right? When you throw 5,400 pounds into a sharp turn, centrifugal force wants to roll the body of the car toward the outside of the corner.
Yeah, traditional cars use thick steel anti-roll bars connecting the left and right suspension to resist that lean.
But Mercedes threw out the steel bars entirely and developed AMG active ride control.
Instead of a passive piece of metal, these shock absorbers at all four corners are interconnected by a central network of highly pressurized hydraulic lines and valves.
So when you turn hard left and the weight of the car wants to compress the right side suspension, the computer instantly pumps hydraulic fluid into the shock absorbers on that right side, artificially stiffening them.
At the same time, it adjusts the pressure on the left side to keep the tire planted. It actively pushes back against the body roll in milliseconds.
The car simply refuses to lean.
It's wild. And when mechanical grip from the tires and hydraulic suspension isn't enough, they utilize aerodynamics to manipulate the air beneath the car.
Yeah, the technical dossier details these Venturi flow plates hidden in the carbon fiber underbody. When the vehicle reaches 75 miles per hour, about 120 kilometers per hour, these plates physically drop down toward the asphalt.
It's an application of Bernoulli's principle. Think of a wide river suddenly flowing into a narrow canyon. The water has to speed up to get through the restricted space.
Okay, yeah.
When those plates drop down, they intentionally narrow the gap between the car and the road.
So the air rushing under the car is forced to speed up, and fast-moving air has lower pressure than slow-moving air.
Right. And that difference in pressure creates a vacuum effect. It physically pulls the chassis toward the road, increasing the tire's friction without adding the weight or drag of a massive rear wing.
And all of these systems, the steering, the hydraulics, the aero, are overseen by a central computer system called the AMG race engineer, right?
Yeah, which drivers can tweak via dials on the steering wheel, controlling 9 distinct levels of traction slip.
Okay, so with predictive thermal modeling, managing the battery, hydraulic fluid artificially leveling the suspension, active aero sucking the car to the ground, and a supercomputer distributing 11,169 horsepower to 3 separate motors, I have to ask.
What's that?
At what point are you actually driving the car? And at what point are you just providing a steering suggestion to an algorithm?
Wow, yeah. That is the defining philosophical question of this new era of performance.
It really is.
I mean, engineers argue that the computer isn't stealing the driving experience. It's the only mechanism capable of translating a human's intentions into reality when dealing with a vehicle of this mass.
So the supercomputer is basically the mandatory translator between the driver's desire and raw physics.
Precisely. And the idea of translating human desire transitions perfectly into the most polarizing aspect of this entire project.
Oh, the artificial engine sounds.
Yeah. Mercedes acutely understands their target demographic. They know AMG buyers have a deep emotional attachment to the visceral drama of internal combustion.
They love the roar of a V8, the slight vibrations in the steering wheel, the mechanical jolt of a gear shift.
But because an electric motor is naturally silent and perfectly smooth, Mercedes engineered a system to digitally fake all of those mechanical imperfections.
They call it the AMG Force S Plus system. And it's a fascinating study in automotive skeuomorphism.
Subomorphism.
Yeah, designing a new technology to retain the ornamental features of the old technology it's replacing, simply to make humans comfortable. Like how a smartphone camera plays a fake shutter click sound when you take a photo.
Oh, right, exactly. And the Arena AV article breaks down just how far Mercedes took this concept.
It's pretty far.
The system dynamically mixes 1,600 individual sound files recorded from their old gas-powered AMG GTR.
1,600 files just for engine noise.
Yes. It continuously analyzes the driver's throttle input and speed to pump a highly realistic synthetic V8 rumble into the cabin through the speakers.
And it projects that sound outward, too, utilizing external speakers so pedestrians hear a V8 engine approaching.
Which is legally required to some extent for EVs, but not to this level of mimicry. And they went far beyond just playing an audio track.
Right. The software intentionally commands the electric motors to generate artificial powertrain vibrations.
The motors intentionally stutter to simulate the feeling of a gas engine idling.
That is just, it's so bizarre. And when you accelerate, the computer will momentarily interrupt the torque delivery to mimic the physical jolt of a transmission shifting gears.
It creates the illusion of a multi-speed gearbox. Even though these axial flux motors deliver seamless, continuous power without needing to shift at all.
It's like buying a state-of-the-art smartwatch, but insisting it be programmed to tick loudly and require you to virtually wind it every morning just to feel authentic.
That's a perfect analogy. Automakers are discovering a profound psychological truth during this EV transition.
Which is?
The things we used to categorize as the flaws of internal combustion, the noise, the vibration, the slight hesitation before a surge of power, those weren't actually flaws.
Oh, interesting.
They were the feedback mechanisms that connected the human being emotionally to the machine. Without that tactile feedback, an electric car, no matter how fast, can feel like a highly efficient appliance.
I can see that. And the interior design leans heavily into that high-tech appliance aesthetic, too. It abandons the analog gauges of a traditional sports car for expansive digital real estate.
Yeah, there's a 14-inch screen dominating the center console and another dedicated 14-inch screen purely for the passenger.
And the infotainment system integrates AI, specifically ChatGPT, for conversational voice commands.
They also integrated a Skyway control panoramic glass roof. The glass can instantly change its opacity at the touch of a button, and it features embedded projectors that can display a starry night sky or, somewhat inexplicably, racing stripes directly onto the glass above the occupants.
Racing stripes on the roof glass. Okay. Well, when you combine the artificial V8 vibrations, the AI-integrated screens, and a low-slung, sweeping exterior design heavily inspired by their futuristic Vision EQXX concept car, the public reaction is fiercely divided.
Yeah, we spent some time in the reader comments on the Arita EV article, and automotive enthusiasts are not holding back their opinions.
Not at all. The comments section provides a stark contrast to the polished marketing language. It reveals a deeply entrenched resistance from purists.
While some readers praised the technological leaps and the luxurious interior, the exterior styling and the concept of a simulated engine drew heavy fire.
One commenter plainly called it the company's ugliest car yet. Another referred to the sweeping design as cheap, comparing it unfavorably to a new electric sedan released by the tech company Xiaomi.
Someone simply left a vomit emoji.
Yeah, and we have to view these reactions through the lens of price, too. Representatives indicate this vehicle will cost somewhere between $200,000 and $300,000 once fully optioned.
That is a staggering financial commitment for a vehicle that serves as the first draft of a new era. It is brilliant, and the battery and motor technologies are genuinely revolutionary.
Wow.
But it is also highly experimental in how it attempts to bridge the emotional gap between two completely different philosophies of motoring.
Well, let's pull all of these threads together. Today, we've explored 11,169 horsepower engineering triumph. We looked at how axial flex motors rethink the geometry of magnetic force to deliver repeatable hypercar acceleration.
We saw how predictive mathematical models manage the massive heat generated by 11-minute fast charging.
We unpacked the physics of how interconnected hydraulics and active aerodynamics force a 5,400-pound battery to carve through corners like a sports car. And yet, for all its futuristic capability, it still relies on software to pretend it has a gas engine, just to elicit an emotional response.
It is a profound technological achievement wrapped in a very human psychological compromise.
It truly is. But before we close out, I want to take a moment to speak directly to you, our listener. Thank you. We know your time is valuable, and we appreciate you choosing to spend it taking this deep dive with us.
We really do.
It's your curiosity, your drive to look past the surface level horsepower numbers and really understand the intricate why and how behind the technology shaping our world that makes exploring these sources so rewarding. We genuinely love putting these deep dives together for you.
And as you go about the rest of your day, I'll leave you with this final thought to ponder. If we are now capable of engineering an electric vehicle that achieves smooth, silent, and seamless perfection, but we feel compelled to deliberately program it to stutter, vibrate, and roar just so we can feel emotion, what does that reveal about what we actually value in the machines we build? Are we engineering the human experience out of our technology only to artificially simulate it back in?